Hello dear children, today we are going to learn about the chapter number 1st, gravitation. The objective of the lesson are: number 1, the concept of gravitation, circular motion and centripetal force, Keplers law, Newton's universal law of gravitation, acceleration due to gravitational force of the earth, free fall and the concept of escape velocity. Dear children, we already studied that the gravitational force is a universal force which acts not only between two objects on the earth but also between any two objects in the universe. Let us learn more about the gravitational forces. As we study the phenomena of gravitation, which is discovered by a great scientist, Newton, we know very well the history of the gravitation. Newton discovered the force seeing an apple fall from a tree on the ground. He wondered why all apples fall vertically downwards and not at an angle of the vertical. Why do they not fly off in a horizontal directions? After a lot of thinking, the scientists came to know that the earth must be attracting the apple towards itself, and this attractive force is directed towards the center of the earth. The direction from the apple on the tree to the center of the earth is the vertical direction at the position of the apple, and the apple falls vertically downwards. Dear children, Newton thought that if the force of gravitation acts on apple on the tree at different heights from the surface of the earth, can it also act on the objects at even greater heights, much further away from the earth? Dear children, Newton thought that if the force of the gravitation acts on the apple on the tree at different heights from the surface of the earth, the gravitational force will act on the objects at a greater height. For example, the moon. The gravitational force acts on the moon because the moon is far away from the earth. Can it act even further objects like other planets and the sun? Dear friends, the apple tree on the earth, the force on an apple is towards the center of the earth, that is along the perpendicular from the position of the apple to the surface of the earth. The gravitational force between the earth and the moon. Dear children, now we are going to learn about the Keplers Laws, which is also called the planetary motion observed by the astronomers. Before Galileo, all observations of the planets' positions and the motions made with the help of naked eyes. Kepler studied the position of the planet and the motion of the planet on the basis of his data what he collected. He noticed that the motion of the planets follows certain laws. He stated 3 laws describing the planetary motion. Let's see one by one. Kepler's first law of motion states that the orbit of a planet is an ellipse with the sun at one of the foci. Dear children, the elliptical orbit of a planet revolving around the sun The position of the sun is indicated by the letter S. Kepler's second law states that the line joining the planet and the sun sweeps equal areas in equal intervals of time. The children, as shown in the figure, A, B and C, D are the distances covered by the planet in equal time, that is, after equal intervals of time. The positions of the planet starting from A and C are shown by B and D respectively. The straight lines AS and CS sweeps equal area in equal intervals of time, that is, area ASB and CSD are equal. This is the second law. Let's see the Kepler's third law of motion. The square of its period of revolution around the sun is directly proportional to the cube of the mean distance of a planet from the sun. This is nothing but the Kepler's third law of motion. If r is the average distance of the planet from the sun, so t is its period of revolution. On the basis of this, t square is directly proportional to r cube. That is, t square upon r cube is equal to constant, is equal to k. Kepler's obtained laws simply from the study of the position of the planets obtained by regular observations. So regular observation is also very important. Dear children, Kepler had no explanation as to why planets obey these laws. We will see these all laws helped Newton in the formulation of his theory of gravitation. Let's see the Newton's universal law of gravitation. Dear children, Keplers laws led Newton to formulate his theory of universal gravity. According to this theory, every object in the universe attracts every other object with a definite force. This force is directly proportional to the product of the masses of the two objects and is inversely proportional to the square of the distance between them. Dear children, as shown in the figure, just consider m1 is the mass of first object and m2 is the mass of second object. So here we are going to consider the two objects. M1 and M2 are the two objects. M1 and M2 are the masses of first object and second object respectively. Both the objects kept at a distance from each other. Mathematically, the gravitational force of attraction between these two objects can be written as F is equal to G M1 M2 upon D square. D is nothing but the distance between the two objects. Dear children, capital G is the constant of proportionality, which is also called the universal gravitational constant. Dear friends, mass of one object, you just consider if the mass of one object is doubled, the force between the two objects also doubles. If the distance is doubled between the two objects, then the force decreases by a factor of 4. If the two bodies are spherical, the direction of the force is always along the line joining the centers of the two bodies, and the distance between the centers is taken to be d. In case where the bodies are not spherical or have irregular shape, then the direction of the force is along the line joining their centers of mass, and d is taken to be the distance between the two centers of mass. Dear children, the value of g is the gravitational force acting between the two unit masses kept at a unit distance away from each other. SI unit, the value of g is equal to the gravitational force between two masses of 1 kg kept at 1 meter apart from each other. Dear children, the SI unit, the unit of g is Newton meter square per kg square. Dear children, the mass of an object is concentrated at its center of an object. The center of mass of a spherical object having uniform density is at its geometrical center. The center of mass of any object having uniform density is at its centroid. This is all about the Newton's universal laws of gravitation.
Law of universal gravitation. In his law of universal gravitation, physicist Sir Isaac Newton proposed that every object is attracted to every other object with a force directly proportional to the product of the masses of the objects and inversely proportional to the square of the distance between them. Newton's law of gravitation can be expressed in an equation. Fg is equal to g multiplied by m1 multiplied by m2 whole divided by r squared, where Fg is the force of gravity between two objects of mass m1 and m2. R is the distance between the center of the two masses, and g is the gravitational constant. The value of g was determined by scientist Henry Cavendish as g is equal to 6.67 times 10 power minus 11 meter square per kilogram square. The law of universal gravitation implies that the greater the masses m1 and m2, the greater the forces of attraction between them will be. If the mass of one object is doubled, the force will be doubled. If one mass is reduced by half, the force will also be reduced by half. But if both masses are doubled, the force between them will be quadrupled. Similarly, distance and force are inversely related. The greater the distance between the two objects, the weaker the force of attraction. If the distance between two objects is doubled, the force of attraction will be reduced by 1/4. If the distance is halved, the force of attraction will be quadrupled. The attraction between two objects is a consequence of Newton's third law, which states that every action has an equal and opposite reaction. In this case, the gravitational force, Fg, acting on particle m1 is equal and opposite to the gravitational force acting on particle m2 minus Fg. The force of gravity is a vector quantity. Object m1 will attract object m2.
Now we are going to learn about the Earth's gravitational force. Dear children, Earth attracts every object near it towards itself because of the gravitational force. The center of the mass of the Earth is situated at its center. So the gravitational force on any object due to the Earth is always directed towards the center of the Earth. Because of this force, object falls vertically downwards on the Earth. When we throw a stone vertically upwards, this force tries to pull it down and reduces its velocity. Due to this constant downward pull, the velocity becomes zero after a while. The pull continues to be exerted and the stone starts moving vertically downward towards the center of the earth under its influence. This is nothing but the earth's gravitational force. Here we can understand that the earth attracts the object towards its center. Difference we can consider like that: if earth attracts the apple toward itself, at the same time the apple will also attract the earth toward itself. Yes, it's a very interesting point to be think. Difference: why does the apple fall towards the earth but the earth does not fall or move towards the apple? Yes, gravitational force due to the earth also acts on the moon, because of which it revolves around the earth. Moon revolves around the earth because earth exerts the gravitational force on the moon. The moon and artificial satellites. Similarly, the moon and artificial satellites orbit the earth. The earth attracts them towards itself, but unlike the falling apple, they do not fall on the earth. Why the planets and the moon do not fall on the earth? This is because of the velocity of the moon and the satellite along their orbits. If this velocity was not there, they would have fallen on the earth. So this is all about the earth's gravitational force.